Example 5 talks about the pulse rates of adult females. Because these are pulse rates which occur naturally, this will be a normal distribution. Pulse rates of adult females are normally distributed with a mean of 74 beats per minute and a standard deviation of 12.5 beats per minute. What is the percentage of adult females? Hi, Bobby. What is the percentage of adult females with pulse rates below 49 beats per minute? So let's draw a normal distribution. My mean is 74. I go 1, 2, 3 standard deviations above the mean. And 1, 2, 3 standard deviations below the mean. So we need to take a look. My standard deviation is 12.5 beats per minute. So I'm going to take 74 plus 12.5 to me 86.5, 86.5 plus 12.5 to get me 99, and 99 plus 12.5 to get me 111.5. I also need to go 3 standard deviations below the mean. So I'm going to go ahead and subtract from 74 12.5. That gives me 61.5. Again, I subtract 12.5. That puts me at 49. And I subtract a third 12.5 because I want to be 3 standard deviations below the mean. That gives me 36.5. Just got to open the blind so my kitty can look out the window. There you go, Bobby. So I want to know, what is the percentage of adult females with pulse rates below 49 beats per minute? So I want to know what the percentage or the area is of this little area over here. Now I know that 49 marks the second standard deviation. So using the 68, 95, 99.7 rule, I have 95% of data. That means that I got 5% left over. So we take 100 minus 95, I get 5% left over, but that's distributed between 2 tails because our graph is symmetrical. So that leaves me with 2.5% in each tail. So the percentage of adult what was that? The percentage of adult females with pulse rates below 49 beats per minute was 2.5%. Now, this is great. The 68, 95, 99.7 rule, great. Super easy to use. Here's the issue. What if I wanted to know the percent of people who had pulse rates below 77% or above 102? Those don't fall on nice standard deviations, and that's when we need to talk about something called Z-scores. The number of standard deviations above or below the mean is called the standard Z-score. And what you do is you take your data value minus your mean and divide it by your standard deviation. That will give you your Z-score. What does the Z-score mean? We're building up to that, but first we need to know how to calculate our Z-scores. If my data value is above the mean, my Z-score, or also known as a standard score, is going to be positive. And if my data value is below the mean, I'm going to get a negative Z-score. So let's go ahead and calculate some Z-scores using this example. The Stanford Bennett IQ test is scaled so that its scores have a mean of 100 and a standard deviation of 15. We want to always round our Z-scores to the hundredth place, so 2 digits, friendly reminder. Not a reminder, a new thing, friendly new thing. So let's find the Z-scores for IQ scores of 85, 100, and 125. So we can sketch our little normal distribution, but we don't have to do the whole 3 standard deviations above or below the mean. I've got 100, I've got 85, I've got 125. Let's go ahead and calculate these Z-scores. Remember, my Z-score is my data value minus my mean over my standard deviation. So for 85, I have 85 minus 100 over 15. That gives me negative 15 over 15, which is negative 1. So 85 has a z-score of negative 1. Let's do the same thing for 100. I take 100 minus my mean, which is also 100, over 15. I get 0 divided by 15, which is 0. So the mean, which is already at the mean, it's already there. It has a z-score of 0. And for 125, I would take 125 minus 100 divided by 15. So I get 25 divided by 15, which is 1.67. Okay, so now I know that 125 is 1.67 standard deviations above the mean. And 85 is negative 1 standard deviations below the mean. So that'd just be 1. It's just 1 standard deviation below the mean. And we know that because my z-score is negative. So how can we learn to interpret these z-scores? So for z-scores, once we know the z-score of a data value, we can go to the ZTable. This is Appendix A in your text, and I believe it's pages 378 and 379. If anyone would like an extra printed copy of this, let me know, and I'll be sure to get you one. So once we know the z-score of a data value, we can use the normal distribution to allow us to find the percentile of the distribution. This is usually done with a z-score table, as you can see here. So let's zoom in a little bit. So if I have a z-score of 0, right, that's the mean, I'm at the 50th percentile. So 50% of data is less than the mean. If I am 1 standard deviation above the mean, that means that 84% of data is less than my data value. If I have a z-score of 1, that means I've got 0.84% of data less than that value with a z-score of 1. And as long as our data is normally distributed, this always works. If I have a z-score of negative 2.7, that means that 0.0035 or 0.35% of data values are less than negative 2.7, and that makes a lot of sense, right? Because we use 2 standard deviations above or below the mean to mark the outliers. So there shouldn't be a lot of data below 2.7 standard deviations from the mean. So why don't we use the appendix A1, use appendix table A1, that's for our z-scores, to interpret the percentiles that correspond to the standard scores found in example 6. So we found that 85 has a z-score of negative 1. Let's go to our table. So I've got 2. I've got 1 for my negative z-scores and 1 for my positive z-scores. So let's zoom in. I go to negative 1.00. We've got our second decimal up there. That's why we rounded 2 decimal places. And I have 0.1587. So from my z-score of negative 1, I got a z-table value of 0.1587. I'm going to take that back, and that means if I have a z-table value of 0.1587, I can multiply that by 100 to get 15.87%, which is about 16%. Also, that would mean that 85 marks the 16th percentile. That would also mean that if at 85, the area to the left of 85 is 0.1587. This area right here is 0.1587. Remembering that the area under a normal curve is 1. If 100 has a z-score of 0, we go ahead and we look at our Z-table and we see a Z-score of 0.00 marks 0.50. And that makes sense, right? If you have a Z-score of 0, you're the mean, and you divide our data in half. So 100 has a Z-table value of 0.5000. If we take that times 100, that is our 50%, so that would be the 50th percentile. And that would mean the area to the left of it on a normal curve, this whole area, would be 0.50. Next, let's take a look at a Z-score of 1.67. Let's change colors. For 125, we'll use blue. So I go to my Z-table, and I find 1.6, and I go over to 1.6.7, and I find a Z-score of 0.9525. Let's go back. So I have a Z-table value. My Z-score of 1.67 has a Z-table value of 0.9525. So that would be 0.9525 times 100 would be 95.25%. So we could say that marks around the 95th percentile. That means that 95% of data values are less than 125. So the area in blue, all of this, will be 0.9525. And the area under the entire natural curve is 1. Natural curve. Normal curve is 1.